In my Maglite upgrade video, I rebuilt my Maglite into an extremely capable commuting light that I now use daily on my early morning Segway rides to work. Another Maglite replacement bulb I came across during this project was the ASF XHP50. It was a bit much for what I needed for my commute, but as a challenge for my next project, it seemed perfect. To see how I construct a new PVC Uber flashlight using this 5000 lumen monster, stay tuned. I initially thought this project would be a challenge due to the potential heat generated by an 8 amp bulb. Thanks to some help from Matt Smith of asflashlights.com, he confirmed for me that the bulb does not create enough heat to melt PVC and that the aluminum housing for the LED only gets to a temperature of 140 degrees and I'm hoping Fahrenheit. With that challenge no longer existent, I'm still anxious to see what this bulb can do, so maybe a new challenge would be to make the simplest PVC flashlight build using the least number of parts possible. I think that could be useful for some of you. Let's get started. I think I've come up with an idea for an easy to build flashlight. Results may differ for you depending on the size of the replacement bulb, so keep that in mind. For the bulb housing, I'll need the replacement bulb, a 2-inch cap, and a 2-inch to 1 1/4 inch reducer. Cut a hole in the 2-inch cap slightly smaller than the diameter of the replacement bulb. Keep the hole centered as much as possible. I didn't want my cutout to look rough, so I went out and bought a hole saw the exact size needed to make this cut. Put the bulb in the 2-inch side of the reducer, then place the 2-inch cap over it and press down tightly to keep the bulb in place. The concave inside of the cap pressing on the bulb keeps it centered on the reducer. And this is our bulb housing. For the battery compartment, I'll need the 1 1/4 inch PVC pipe and cap, a flat metal strip, springs, and some miscellaneous items like screws and glue. Cut a piece of 1 1/4 inch pipe about 4 inches longer than the length of 6 D-cell batteries. Cut a length of flat metal strip about 2 inches longer than the PVC pipe. Because I'm using a tape measure for a metal strip, I'm sanding off the paint to allow better electrical conductivity. If the spring you have is taller than the height of the bulb post sticking up from the center, cut the spring to be slightly shorter than that height. You'll see why shortly. Solder one of the springs about 1/4 inch from the end of the metal strip. Solder the end of the spring that is furthest from the end of the metal strip. I soldered 2 of the loops of the spring. Dry lube one end of the PVC pipe and insert it into the bulb housing as far as it will go. As you can see, the PVC pipe should bottom out inside the bulb housing. I now need to reassemble the bulb housing before drilling the pilot hole through both the housing and the compartment, so everything will remain assembled as it is right now. To not drill into the aluminum bulb housing, insert the drill bit far enough into the drill so that the amount of bit sticking out is only enough to drill through the layers of PVC. It's best to be short on the first drilling, then slide the bit out slightly and drill into the same hole again until you see a slight bulge on the inner wall of the PVC pipe. Also, the hole should be drilled where it will be at about the middle of the reducer for the bulb housing. The screw only needs to go partially into the inner PVC pipe that is the battery compartment and not go all the way through. If it does protrude from the inner PVC pipe, take out the screw and cut it to length so it fits correctly. Put some dots of glue on the other flat side of the metal strip opposite each strip of tape, then insert it into the PVC pipe. Be sure the spring goes in first and rest on the aluminum bulb housing at the other end. Use the batteries to weigh down the metal strip while the glue dries. The tape is there to keep the glue from getting on the batteries. To be sure the spring stays pressed against the aluminum bulb housing until the glue dries, use tape to apply pressure to the end of the metal strip sticking out of the PVC. Let the glue dry for 24 hours. Doing the cap is almost an entire process in itself, so I'm going to treat it as such. For the cap, we're going to need the same 1 1/4 inch PVC cap mentioned earlier, a 2-inch long spring, a sheet of steel or copper about 2-inch square, a 1/4 inch threaded bolt, and 2 1/4 inch nuts. Mount the metal sheet to a drill bit and spin it to draw a circle about the size of the 1 1/4 inch PVC pipe. Cut out the circle slightly inside the line. Drill the center hole using a 1/4 inch bit to fit the 1/4 inch bolt and nut. Mount the circle onto the bolt and secure it using the nut. Mount the bolt on the drill, then spin the circle and file the edges smooth and to size. Confirm the circle fits in the PVC cap. Drill a 1/4 inch hole in the center of the cap. Use the circle to help center the hole in the cap by drilling through the circle's hole and through the cap. Center the nut over the 1/4 inch hole of the circle, then glue it in place. Using the bolt through the circle will help with this. I want to mention, I decided to upgrade my build slightly. As I was shopping for a proper spring to fit the cap, I came across some parts I felt would help dress up my project. Here you can see on the left, I now have a knob. I also picked up different sized bolts and springs to see how different lengths work out. After some test fittings with different combinations of springs and bolts, these are the parts I think will work best. I've screwed the circle onto the bolt just enough so when it's bottomed out in the cap, the head of the bolt will be flush with the rim of the cap. Now I can glue the spring in place. The bolt head will help to keep it centered in the circle, and the cap will allow me to put some stable weight on the spring while the glue dries. Put all the batteries into the flashlight and measure the exact distance from the nearest battery to the edge of the PVC. I have 2 25/32 inch. Now, measure the exact distance from the circle to the end of the spring. This measurement is 1 7/32 inch. Subtract the measurement of the spring from the measurement of the battery compartment, then add 1/4 inch. This final number is the amount of PVC that has to be cut from the battery compartment. For me, the subtraction step came out to 1 18/32 inch. Then adding 1/4 inch made that 1 26/32 inch or 1 13/16 inch. Mark where the cut line should be on the PVC. Carry this mark around the circumference of the PVC so you'll know what a straight cut should look like. Cut the PVC, staying on the line as much as possible. The reason you want this cut to follow the line is because if the battery compartment edge is crooked or slanted when the circle is pressed against it to complete the circle could bend. This would prevent completing the circuit at a later time as the circle repositions itself periodically from turning the flashlight on and off. Now that the PVC pipe is cut to length, cut off the metal strip but leave about 1/4 inch for the next step. Because I'm using a tape measure, I'll again have to sand off the paint to expose the bare metal underneath, which aids in electrical conductivity. Cut slits in the metal strip sticking out of the PVC, then bend each cut strip down over the edge of the PVC pipe. This is where the steel circle will contact the metal strip and complete the circuit that will turn the light on. Glue down each metal strip to the PVC pipe edge. The bent metal strip may not stay down against the PVC edge, so you'll have to find a way to either weight it or clamp it down. Let dry for 24 hours. Press the cap onto a scrap pipe till it's tightly on, but easily removable. Then mark a line on the pipe at the cap's edge. Remove the cap and mark this same distance on the cap. Screw the circle end nut onto the bolt, leaving about 3/4 inch between them. Insert the bolt into the cap, and with the nut bottomed out in the cap, tighten or loosen the nut until the circle is roughly in line with the line drawn outside the cap. When you've got it about right, Loctite it in place and let dry for a few hours. Once the Loctite has dried, put the 1/4 inch washer on, insert the bolt into the cap, and screw the knob on tightly. This is a last minute step I'm adding, which could probably be done before making the on-off switch. Remove the knob and take out the bolt. In preparation for the next step, I drew a line on the cap 1/2 inch from the edge. On that line, I made 2 divots about 1/2 inch apart using a small drill bit. Put the cap on the battery compartment till it's snug and easily removable. The 2 divots on the cap must be on the opposite side of the battery compartment from the metal strip. Drill a 15/64 inch hole in the left side divot. Drill through the cap and the battery compartment. Remove the cap and now drill the hole that was just drilled and the divot next to it to 1/4 inch. Mark connecting lines to both holes to form an L-shaped notch. Trim away the plastic to create an L-shaped notch in the cap. I started out using a hacksaw to cut from the edge of the cap to the first hole. Then I used some kind of 1/4 inch shaving bit to grind the cut between the 2 holes. Finally, press the dowel into the battery compartment. Although the dowel is 1/4 inch, I found that drilling a 15/64 inch hole as opposed to drilling a 1/4 inch hole allows the dowel to be press fit into the hole without using any glue. If the dowel does happen to come loose in the future, you could use crazy glue at that time. Now you can see the reassembled switch with the new cap locking mechanism. Just line up the notch opening with the dowel, slide in, and turn. That should keep the cap in position when the on-off knob is overturned, especially when turning the flashlight on. Turning on the flashlight is just a matter of turning the knob counterclockwise till the light turns on, and turning it clockwise to turn it off. One feature I like about my on-off switch is its ability to turn on temporarily by first turning off the light, then pressing and releasing the knob to toggle the light on and off. Because this bulb has different modes it can be set up for, you'll have some homework to review in the description. Look for the section named Modes of Operation for ASF XHP50. Here I'm going to demonstrate changing the current multi-intensity mode to a 100% only intensity. With the flashlight turned off, press the knob down to keep the light on for at least 3 seconds. Quickly release and press the knob 8 times, then keep the knob pressed on the 8th time. The flashlight should begin blinking. On the chart, 100% only is 9 presses, so once the light starts blinking, do the same press and release 9 times. When you see the light flash, that means it's now set to the new mode. This project was a lot of fun for me, and what really helped were the bulb and housing combos that are available from Adventure Sport flashlights. It helps that Matt Smith from ASF is an avid flashlight professional. Check out his YouTube channel if you have any interest of this sort. I think even if you don't, you'll be amazed at some of the flashlights this guy reviews. If you have any questions or comments, leave them in the comment section below. That's all I have for now, and I'll catch you in the next video.